Interpret a quadratic graph. Okay. So very similar to the last one. See, a certain company's main source of income is a mobile app. Think of any app on your phone. The function models the company's annual profit in millions of dollars as a function of price they charge for the app. So we have a graph. See here, let's check all the ones that apply. So the company's profit will be $0 if they don't charge for it. So that's actually wrong. So if they don't charge for it, let me snip this so I can talk about it. Okay, so if they don't charge for it, we are app price is the x-axis, so $0 is right here. I guess they don't make a profit. I was going to say that it's wrong because they're actually losing money, but I guess that's also true now that I think about it. They're not making a profit. They're actually also losing money. I think, it says it'll probably be 0 if they don't, so actually that's wrong. That is not correct. The profit will be less than 0, actually at -10. The company's profit will be at 0 if they charge about $1 or about $13 for it. So $1 is here and 13 is here. And that is about 0. Okay, we're approximating. So that statement is true. C and D. Greater app price relates to smaller profit as long as the app's price is less than about $7. So greater app price relates to smaller profit. So here's $7. And it's saying that if we increase the price, it results in a smaller profit as long as the app is less than $7. It's actually backwards. As we increase the price to 7, we are increasing profits. After 7 is when we start losing profits. So that one's not correct. I bet you'll be backwards. Greater app price relates to smaller profit as long as the app price is more than $7. So that's the one that's correct as well. Because once we get past 7, which is here, now we're starting to lose money again. Okay. Let's see here, let me snip it. Actually, let's see if I can snip everything so we can talk about all in one image. A little smaller. There we go. Okay, that should be good right there. Okay, let's read the scenario first. Sarah kicked a ball in the air. We kicked a ball in the air. That's the scenario. All right, the ball moved upwards for about 3.5 seconds. So here's where the ball is kicked. It's slightly above ground because it's off of a foot, not the ground. It's going up for 1.75 seconds. And then it's going back down until about 3.5. The ball moved upwards for about 3.5 seconds. That is not true. The ball started moving upwards for about 1.75 seconds. That is that number. This one is true. The ball hit the ground after about 3.5 seconds, and that's what we have there as well. Looks like B and C are correct, and D is saying the ball hit the ground after 1.75. We know that's not true. So B and C are correct here. I misread that. The ball started moving upwards after 1.7. I thought it was saying it's going up. Yeah, so it's only C. There you go. Yeah, I misread that one. Sorry. Next question. Okay, let's snip it. Try and get both of them right this time. Okay, let's read the scenario. What is the scenario here? Simon has a certain length of fencing to enclose a rectangular area. So we're creating a yard. Greater width always relates to smaller area. So here's our width. Well, as we increase our width, going this direction, our area increases. Well, greater width always relates to smaller area. That's not true, because from here all the way to this point here, so at 10, as long as we have an area increasing to 10, our area is increasing. After our width gets bigger than 10, it starts to decrease. Greater width relates to smaller area as long as the width is less than 10 meters. That's also wrong, because until we get to 10 is when it's our area keeps increasing until we get to 10. When there is no width, the area is 20 meters squared. So here's no width. We have 0 area. When there is no width, the area is 0. So it's only B here. Let's hope. All right, one more. Mosquito question. Everyone's worst nightmare. The function models the number of mosquitoes in a certain area as a function of rainfall. So more rainfall relates to more mosquitoes as long as rainfall is less than 2 centimeters. So here, this is rainfall down here, and this is mosquitoes up here. A number of mosquitoes. I didn't spell that right. We'll put 2 I's in there. There we go. So more rainfall relates to more mosquitoes as long as rainfall is less than 2 centimeters. So as rainfall increases, so does our mosquitoes until right here, and that is at 2 meters. So A is true. More rainfall relates to more mosquitoes as long as rainfall is more than 2 centimeters. Well, after 2 centimeters, it starts to decrease. So B is wrong. When there's no rainfall, there are about 1 million mosquitoes. No rainfall is here, which means we have 0 mosquitoes. That one is wrong. When there is no rainfall, there are about 2 million mosquitoes. Once again, no rainfall means we have 0 mosquitoes. So A is the correct answer for this one.